What's up mga iis?
Electrical measurements are the methods, device, and calculations used to measure electrical quantities. Measurement of electrical quantities may be done to measure electrical parameters of a system. The standard units of electrical measurement used for expression of voltage, current, and resistance are the volt, ampere, and ohm, respectively. These electrical units of measurement are based on the International System, also known as the SI system, with other commonly used electrical units being derived from SI-based units. The standard electrical units of measure. Multiples and submultiples of the standard unit. The Permanent Magnet Moving Coil or PMMC instrument. It is an instrument which uses the permanent magnet for creating the stationary magnetic field between moving coils. It operates on the principle that the torque is exerted on the moving coil placed in the field of the permanent magnet. DC ammeter. Ammeter is an instrument used for measuring electrical current. In order to measure an electric current, an ammeter must be connected so that the total current of interest can pass through it. In other words, the ammeter should always be connected in series to the circuit or component being measured. Ammeter shunt. The ammeter shunt is the device which provides the low resistance path of flow of current. It connects in parallel with the ammeter. Ammeter are designed for measuring the low current. For measuring the heavy current, the shunt must be connected in parallel with the ammeter. Multi-range ammeter. Switch shunt. The current range of the DC ammeter may be further extended by a number of shunts selected by a range switch. Such ammeter is called the multi-range ammeter. Ayrton shunt. Ayrton shunt or universal shunt is a high resistance shunt used in galvanometer to increase the range without changing the damping. DC voltmeter. DC voltmeter is a measuring instrument which is used to measure the DC voltage across any 2 points of electrical circuit. Multiple range DC voltmeter. If we want to use the DC voltmeter for measuring the DC voltage of multiple ranges, then we have to use multiple parallel multiplier resistor instead of single multiplier resistor, and this is intercombination of resistor is in series with the PMMC galvanometer. Ohmmeter. Ohmmeter is used to measure the value of resistance between any 2 points in an electric circuit, and it can also be used to find the value of an unknown resistor. Series ohmmeter. If the resistor value is unknown and has to be measured by placing it in series with the ohmmeter, then the ohmmeter is called the series ohmmeter. Shunt ohmmeter. If the resistor's value is unknown and to be measured by placing it in parallel with the ohmmeter, then that ohmmeter is called the shunt ohmmeter. AC voltmeter. The instrument which is used to measure the AC voltage across any 2 point of electric circuit is called the AC voltmeter. If the AC voltmeter consists of rectifier, then it is said to rectifier-based AC voltmeter. Types of rectifier-based AC voltmeters. AC voltmeter using half-wave rectifier. If a half-wave rectifier is connected ahead of DC voltmeter, then that entire combination together is called AC voltmeter using half-wave rectifier. AC voltmeter using full-wave rectifier. If a full-wave rectifier is connected ahead of DC voltmeter, then that entire combination together is called AC voltmeter using full-wave rectifier. DC bridge circuit. The DC bridge measures the unknown resistance of the circuit. This ingenious circuit make use of a null balance meter to compare two voltages, just like the laboratory balance scale compares two weights and indicates when they're equal. Wheatstone bridge circuit. Wheatstone bridges are considered a superior means of resistance measurement to the series battery movement resistor meter circuit. Slide wire bridge. A resistance measuring device used as a part of a Wheatstone bridge and consisting essentially a straight or spiral wire divided by a sliding contact into two parts forming the whole or known portions of adjacent arms of the bridge. Kelvin bridge. Kelvin bridge is a measuring instrument used to measure a known electrical resistor below 1 ohm. It is especially designed to measure resistors that are constructed as 4-terminal resistors. The Varley loop. The Varley loop is a device containing a Wheatstone bridge for comparing resistances and for locating faults in circuits. The Morey loop. Morey loop bridge is a bridge circuit used for locating fault in underground or underwater cables. One end of the faulted cable is connected through a pair of resistors to the voltage source. Also, a null detector is connected. The other end of the cable is shorted. AC bridge circuit. AC bridges are the circuits that are used for the measurement of electrical quantities such as inductance, capacitance, resistance. Along with this, an AC bridge allows us to measure the storage factor, loss factor, dissipation factor, and etc. AC bridges operates with only AC signal. Applications of AC bridges. Communication system and complex electronic circuitry majorly make use of AC bridges. AC bridge circuits are used in phase shifting and for the filtration of undesirable signals. It is also used to measure the frequency of audio signals. Types of AC bridges. Capacitance comparison bridge. Inductance comparison bridge. The Maxwell bridge. It is a modification of Wheatstone bridge used to measure the unknown inductance. The Hayes bridge. Hayes bridge is the advanced form of Maxwell's bridge. It is also used to determine the self-inductance of the circuit. Searing bridge. The searing bridge is used for measuring the capacitance of the capacitor, dissipation factor, properties of an insulator, capacitor bushing, insulating oil, and insulating materials. Wien bridge. The Wien bridge used in AC circuits for determining the value of a known frequency. The bridge measures the frequencies from 100 Hz to 100 kHz. Attenuator. An attenuator is an electronic device that reduces the power of a signal without appreciably distorting its waveform. An attenuator is effectively the opposite of an amplifier. Voltage divider attenuator. A voltage divider attenuator is created whenever you have two resistors or impedances in series, with the signal takeoff point between the two. Symmetrical T attenuator. A T-pad attenuator is an attenuator network consisting of three non-inductive resistive elements connected together to form a T configuration. Symmetrical pi attenuator. The pi-pad attenuator is so called because its basic layout and design resembles that of the Greek letter pi, meaning that it has a one series resistor and two parallel shunt resistor to ground at the point and the output. Bridge T attenuator. As its name implies, the bridge T attenuator has an additional resistive element forming a bridge network across the two series resistor of the standard T-pad. Variable attenuator. Pin diode. The control element used in most electronically variable attenuators is the pin diode. Pin diodes are used primarily for control of microwave power from the low megahertz frequencies up to millimeter waves. One of the simplest form of variable attenuators is the simple shunt diode type. With this type of attenuator, the user will supply bias current to the pin diode.